So, hello everyone. I would like to welcome you all to this session on basics of Azure. And today's session is going to be conducted by our expert speaker, Divyesh from Puhan. So today we will be going to learn how you can get started with Azure, and I welcome you all to getting started with Azure fundamentals. So the topics that are going to be covered today in today's session are how to create Azure login or password and account, how you can set up your subscription and what are the benefits for students, how you can host an application and set up an Azure virtual machine. So I would like to hand over to Dibyasom.
Hello.
Yeah, hi
Hi,
Dibyasom.
everyone. Thank you for joining the session. As you might have already guessed, this session is about Microsoft Azure fundamentals, and we are going to learn about uh, what is cloud providing first, cloud native computing first, and then we'll see why do we need cloud native computing, and then we'll obviously see how Microsoft Azure fundamentals comes into the picture as one of the leading cloud providers. So I will be doing hands-on into Microsoft Azure. We'll create a virtual machine. We'll of course learn what is a virtual machine, create one, and deploy a project into it. Right. So let me quickly share my screen. If we go on. So I hope my screen is visible to all of you. And yeah. Can someone add my screen to the stage? Yeah, cool. Thank you. Okay, so you're going to start with Microsoft Azure fundamentals. So before that, let's learn why do we need Microsoft Azure fundamentals, or more specifically, why do we need cloud computing in general. So think of a situation that you have a perfectly working piece of code. You want to build. First of all, imagine. Let's visualize a scenario, right? Imagine that you want to build an e-commerce website. You are going to name it my. myamazon.com, right? You're going to create an e-commerce website. You're going to name it myamazon.com, and you want to host it. You want people to be able to purchase things on it, get some orders, and you generate a piece of revenue. That's the last goal. So you write the code for that. You write a piece of code which works really amazing on your system. It does everything that it is expected to. So what's the problem? When are you going to fail, or at what point are you going to fail? So let's imagine an edge case. So today you have only 5 clients, only 5 people actually using your myamazon.com. Now tomorrow you go ahead and do buy some subscriptions and do a promotion on all a paid promotion on all social handles, like you do an Instagram sponsorship, you do on Facebook, LinkedIn, everything. So you go ahead and spread the awareness about the existence of your myamazon.com everywhere. You do some publicity, and the next day, by some miracle, you get, let's say, 1 million customers. So now the myamazon.com, your website, is actually running on your system, on your local system, right? It's using the network connectivity that is available to your system, and it's using the resources on your system, your processor, your RAM, your storage, everything. So is a single system on a household network going to be able to handle this kind of load where 1 million people flow in? No, right? It's going to fail, because in real world, to give you an estimate what kind of data flow happens, if you know about Shopify, it was an interesting tweet. They tweeted about the amount of data flow on one of their peak days. So it was the Black Friday sale, somewhere around last month, and at its peak, the amount of data that was flowing in was more than 40 petabytes per day, right? So more than 40 petabytes of data was flowing in one day, which is like 1 petabyte is 1024 terabytes, and 1 terabyte is 1024 gigabytes. So you can imagine how largely it can scale if regular flow of customers happen. So for those scenarios, you require something better than your system, right? You need some kind of scaling. We'll learn what is scaling, but let's go through this. Let's work up our example. So 1 million people come, and our system is quickly going to quickly run out of resources to address the services of this 1 million kind of traffic. So what do I mean by resources? Imagine your processor. Can the processor handle that kind of load of running the processing required for this 1 million people who are simultaneously online? You are going to quickly run out of RAM, you are going to quickly run out of your storage. So what will you do if you run out of your storage, RAM, and you think your processor is something that is limiting you? So your system right now, let's say, has an i3 processor. So you go to the shop, you get a really monstrous configuration. You update your system, you run make it an i9, you give it 132 gigabytes of RAM, you update everything. But then you see the next day it fails again, because this kind of computing power is nothing if compared to the real world use cases, right? So however you update it, a single system cannot handle this kind of load, right? Like, it's going to fail sooner or later. So what do you do? And what about now? This is just one challenge, that the configuration of the system is not able to handle the real world load. Think about the other challenges, like what if your network crashes, your system is going to be unreachable, and how do people access your myamazon.com, because that runs on your system. Think about a scenario that your computer just reboots, gets a software update, and it reboots. Or what if you go through memory, your hard disk corrupts, and your system does a reboot, and you lose all your data? What happens after that? Right? It's not accessible. So of all these problems need to be solved, because if you want something, if you want your e-commerce website to be reliable, or in general your project to be reliable by people, to build the trust, you need something that is reliable. You need something in which the device is managed on premise, and you need to don't need to worry about this physical entities or physical properties of the system. That should not limit you. You as a developer should only work on the programmatic side of the problem. You should be able to code it, and it should work. That's all we need to care about. And there should be someone who should manage the on-premise solutions that are available, maintain, update, patch the systems on time, and upgrade our system as and when required, and manage the scaling. So this someone is not no one nobody else but cloud native provider. Of whatever cloud native tool you want to choose, you are free to go with that. But this is the reason that you need cloud native computing, right? This is what it enables you to do, so that you can get rid of these on-premise solutions that are associated with the configuration of the system, associated with the scaling, associated with the failures that might happen. You don't need to worry about that. Your cloud provider will handle that. And all you need to do is be a programmer. Think of your code, think of your logic, program it, and that's all you need to do, because cloud native will handle everything else. So now talk about this cloud computing and virtualization. These technologies, there are many different providers, leading providers in this particular role. For example, Microsoft Azure, obviously one of the leading cloud providers. Then there is Google Cloud. Then there is AWS, Amazon Web Services. Now let's start with Microsoft Azure fundamentals. So now, how are these problems that we just talked about solved by a cloud computing and virtualization provider? So cloud computing introduces you something called on demand, wherein you can get anything based on your demand, based on the time, and based on the location wherever you want it. And what is virtualization? Virtualization is a like it's a rabbit hole if we dive into its technology. But in simple terms, virtualization allows you to configure any particular system. Which, for example, I hope all of you have used VirtualBox on your system, right? VirtualBox allows you to install a new operating system within your system. So how does it do that? It allocates some part of your system resources, it reserves some part of your system resources, and makes it available to the other operating system which is running inside it. So it's one of the key thing that virtualization can do. It allows you to allocate or partition different the resources between different software. So imagine there are two softwares running on your system, and what if somehow you make it possible that the four cores of your processor are going to be used by program A, and the rest of the four cores or the remaining resources are used by some other system. If your if your uh, system has, let's say, 4 gigabytes of RAM, then your software 1 can only use 2, and software 2 can only use the rest of the 2 gigabytes. So you are basically splitting your resources through some program, in a through a software or program. And these kinds of softwares allow you to implement virtualization. So one of the if you want to implement virtualization on your own system, you can try out VirtualBox. It allows you to do a lot of things. And it's a complete deep rabbit hole. There is virtualization, there is emulation, simulation. All of these things come under this one umbrella. So more or less, through virtualization you can allocate, you can create a system within a system, right? Let's say there is a huge system, a monstrous system. You virtualize a part of it. Let's say there is a system with 16 cores. You reserve 2 cores out of that, completely isolate from the rest of the system, and run your program securely within it. I'm just trying to build a picture here, right? And now, to see how Microsoft does that, we are going to learn about one very basic functionality provided by Microsoft Azure, that is an Azure virtual machine. So, a virtual machine is the most fundamental basic building block of any service provider. Now, it goes by different name in different cloud providers. Like Microsoft calls it by Azure Virtual Machine. In Google, you might have heard about Compute Engine, and AWS calls it EC2, Elastic Compute 2. So there are, it goes by different name, but this is the basic building block which will allow you to actually actually learn how powerful virtualization is. And on top of that, rest of the resources run, for example Kubernetes, for example application services. All of these things basically are leveraging the virtual machine. And virtual machine is what is called IaaS, infrastructure as a service. That is what you can use through virtual machine. Now let's learn what is a virtual machine. And when we learn what is a virtual machine, we can you can already figure out how it solves all those problems that we talked about with myamazon.com, right? Your own e-commerce website. So think about it. An Azure virtual machine is an on-demand scalable computer resource. So what is on demand? We already talked about it. On demand comes from this virtualization thing wherein you can create whatever kind of system you want from within a huge system. You can create it wherever you want, and you can create it whenever you want. To understand on demand, the term on demand, you can think about Netflix. Imagine you want to watch a movie. Do you really go out into the shop and buy it with buy the cassette, get it back home and watch it, right? Let's say you want to watch a movie at 12 a.m. Can you do that? No, right? Not always possible. So how does on demand come in here? So you get a Netflix subscription, you pay some money, and then you are privileged to access, you're authorized to access any movie within it. You can watch anything you want anytime you want. So imagine that in terms of computing resources. You think that your system is not capable of doing something, or you want your system to be, you want something to be always available. You cannot, you don't want to break down your system by making it always available. So what you do is you go to a cloud native cloud provider, you pay some money, you get a subscription, and you can use their system whenever you want. So that is what on demand basically means. And then it is scalable. Scalable can be of multiple types, but I'll give you an example, a hint, or an example to understand. Scalability comes from the way your system handles load and how uh, robust it is. Like, it should not fail, it should be able to handle huge loads. So if there are 5 people, your virtual machine is doing its job. If 10 people join in your virtual machine, you allocate a new virtual machine, and you balance the load between them, so that system 1 handles 5 people, system 2 handles 2 people. Now if there are 20 people, you allocate 4 virtual machines. If there are 100 people, you allocate 25 virtual machines. So that is how scalability happens. You allocate new virtual system machines, and all those virtual machines handle the new flow of system. Now there is a technical term to it. It's called load balancer. It is what allocates the virtual the traffic to different systems based on the load. There are different kinds of load balancers. Let's not dive into the details, but the names are like network based. Then there is compute based load balancers and things like that. Now, virtual machines are generally used to host applications when the customer requires more control over the computing environment. That is what we mean by infrastructure as a service. You get a complete system and you have access over everything within it, like a complete operating system. And virtual machine, to leverage your virtual machine to host your application, you get the flexibility of virtualization without the need to buy or maintain any underlying physical hardware. So with like, we have done a lot of theory about it. Now let's go and see how to create a virtual machine, and how to host our project into it. So virtual machine, Microsoft Azure. I'm going to go into Microsoft Azure portal. to get a free subscription to get some student benefits, click on start free and just connect your GitHub account into your Microsoft Azure, and you're going to get some free credits. If that doesn't work, then verify your Microsoft Azure account with your college email ID. You will get $200 free credits, or $100 depending upon the kind of student subscription that is available. But the bottom line is that it's free for use during the initial phase. So to create a virtual machine or to see what are the different kind of services available, if you click on all services and go to compute, there are lots of different computing resources available, and all of these do one thing at the core: they provide you computing resources, virtually limitless amount of computing resources. Like, you're never going to be bottlenecked here. Now, there are lots of different ways you can utilize the computing resources. Virtual machine is the most fundamental building block. All the other things that you can see here always use virtual machine at their core as the lowest level functioning system. Like, for example, if you run container instances, here you will think that it's easy to use and you are directly providing a container and it's working, but at its core, it's running a virtual machine. So today we are going to learn about virtual machine, and I'm going to create one here. I'm going to delete one of the previous virtual machines that I had created, so that I don't use a lot of resources and run out of credits. Okay, so now let's quickly create a new one. And in the meantime, if there are any doubts, please let me know. Cool. Right. So let's create a new virtual machine. Let's click on virtual machine, and let's walk through the process of creating a new virtual machine. So first of all, you select this kind of subscription on which you will be built. We are on Azure Students, and it covers virtual machine allocation, so it's not a problem. We don't have to pay any fees. The next systems that are available is actually giving a name to our virtual machine. Let's say I call it my host. Then there is the region. In the region in which you actually want to allocate your virtual machine, the actual machine, because we call it cloud, like it's remote for us, but it's present somewhere, right? Like, where is its actual existence? So that is what this region allows you to do. You choose where your virtual machine will be allocated. And normally, right now, we are doing it for learning experience, so it doesn't matter where we allocate. But in an enterprise or in a company, when you do this thing, you always think about the client location. So if your maximum clients are coming from India, then you would want your virtual machine to be in India. And also, the other things that you need to consider is your data laws. Like, there is GDPR, right? It says that the data must not level leave the country in which your clients are. For example, in European countries, you cannot do that. So those are the two things: your client location and the data laws. But this is for learning, so we don't care about it. Then there are availability options. There are availability zones, virtual machine skill set, availability set. We are going to say no infrastructure redundancy required, because today we don't want backup plans, or we don't want backup resources. We just want to see how virtual machine is created. Then there is security type, and then there is image. Now, image is what allows you to choose what operating system will be allocated or installed on your system when you uh, get it vanilla. So for today's experiment, we are free to choose between Ubuntu Server 20 LTS and 18 LTS. Although these are all the other top a few of the most used operating systems that are available: Red Hat, Oracle, Debian, CentOS, and Windows. And on top of that, you can click on all images to see the entire system plethora of images that are available. Now, size allows you. Now, this is where virtualization comes in. See, I told you that normally when you want to build a computer system, you purchase the hardware, assemble it, do a lot of hard work, and then if you want to upgrade it, you do all of that again. But in here, through virtualization, you can allocate any kind of configuration that you want. For example, that is two virtual CPU mode with 8 gigs of RAM, that is four that with 16 gigs of RAM. And this is just the beginning. If you want to upgrade it on the go, you can do that. You can virtually append more resources into your system, make it maybe 16 core and 64 gigs of RAM. You're free to do that. That's the power of virtualization: zero downtime and quick upgrades. So The next thing is authentication type. We are going to select, make sure that it is SSH public key, because we are going to use the SSH protocol to access our system later. Give it a particular username. So this is the default user that will be created inside your virtual machine. So I'm going to go with my username, because I could not think of better names, and you're free to choose any name you want. It doesn't matter, it's just an identifier. And take a note of this name of the file that will be downloaded, right? And here in inbound ports, make sure that all of these protocols are supported, because we are going to use HTTP today. Now we are going to quickly select the disk type. There are multiple different disk types available. You have for the operating system, you're free to choose between premium SSD, best for production and performance sensitive workloads. Then there are simple SSD or the standard SSDs that are good for web servers, and then there are best for backup. So we are free to choose anything today. Our system does not depend upon read write speeds of the system. So I mean, today's project that we are going to use does not depend upon the read write speed, so we are free to choose anything we want. And then you have the you know flexibility to encrypt your system if you want to, or if you have already allocated a virtual system on your. So if you already have previously allocated a disk on your system on Microsoft Azure, you can also reattach it to any virtual machine. Like if you want to persist your data across virtual machines, this is what you should be doing. And that's another power that virtualization brings to you, right? You don't have to worry about actually physically moving the hardware, you just select a disk from here. Then there is networking. In networking, we are not going to change any configurations here, we'll do that later. But for now, let's see what are the different configurations available. You have a virtual network. A virtual network is the network to which your system will be connected, and you have the flexibility to control each and every aspect of that network. You can control what kind of protocols are allowed, on what ports they are allowed, what are the protocols that can leave the system, everything. So just make sure that RDP is enabled here. We are not going to use today, but RDP is something that you use when you do remote desk protocols, like when you want to use the Microsoft remote desk server, those kinds of things. And then there is load balancing. We don't need any kind of load balancing today. We are the only users today, so we'll be testing our system. Then there are some additional configurations available, like diagnostics, identity, Azure AD. Azure AD once is something you would be using if you are not the only person working on the project, which is going to be 99% of the times. So Azure AD allows you to create active directories, wherein you can authorize different people to access your projects, so that all of them can do whatever they want to do on your system. Like you basically provide access to other people. There is backup, auto shutdown, and guest OS updates. So there are some advanced configurations like virtual machine applications preview. Then there is custom data. Custom data allows you to, if there is some particular thing that you want, some kind of data you want your system to be made available, or if you have a script that should run every time your system boots up, you can write those things here. Those things will be done on every boot up and whenever system starts. Then there is user data, host, capacity reservations, proximity placement groups. These are some advanced configurations which 95% of the times you don't need unless you have a very specific requirement. Then there are tags. Tags allow you to give some identifiers to your system, so that you can identify it from within a group of projects. So let's say that I'll give it a name called purpose today. For this particular system, I'm going to run a Node.js project. So I'll say it purpose today Node.js. You can basically use any kind of key value pair. It's totally up to you. It's just a variable. And after that, we are going to do review and create. So it will run some tests to make sure that whatever configuration we have chosen is actually possible. And once that's done, you will see that validation passed with a green tick. When you see that, just click on create. Cool. So when you click on create, just download the private key and resource, because remember, during the authentication configuration, we selected SSH. So SSH requires a security key to be able to verify that it is really you. And I'm going to use the SSH key that just got downloaded to access the system later. Now, if there are any questions, I'm looking out for that. We are waiting for a Zoom. I do not know about the Zoom meeting star, Barua. Like, if someone can actually clear that confusion. All right. So system deployment is in progress, and okay, in the meantime, let's go to our all resources that we have allocated. Let's find out today's system, the one that we just created. Some things are being created. You see, we created my host, but some other resources are already allocated to us, like my host NSG. My host NSG is the network security group, which controls all the network related protocols that are applicable on your system. Then there is no these are from some previous projects, don't get confused. So what I'm going to do is I'm going to group by resource, so it's easy for us to look at it, and I'm going to call it my host. All right, so these are all the resources that were allocated for today's workshop, right? So we created a virtual machine, but you will see that actually it also created a public IP address, a network security group, a network interface, virtual network, SSH key, disk. So these were all the systems that were required to make it, make it deployable, and for us to access it. So it created all of these things, all of these resources, and allocated it to and authorized us to be able to use all these systems, so that the virtual machine is easy to use. So we have a public IP address where we can access our system. We have a network security group that allows you to configure the network capabilities of your system. Then there is a network interface, the actual device, the underlying device that within the virtual machine allows you to talk to the network security group. Then there is the virtual network, which you configured for an secured access. You can basically actually connect more systems, more virtual machines to this virtual network, and all of the virtual machines can talk to each other through this virtual network. And then there is this SSH key, which is associated with your system, so you can access your system securely. And then there is the disk where your data will be stored. This disk can also be shared across system if you want some persistent data across your systems. So now we are going to go into our my host, and we are going to say connect. Or before doing that, you can see the rest of the configurations here. This is basically the same thing that we configured, and some of the new things that came up after deployment, like the public IP address. This allows you to access your system as a as a client. But now we are going to do connect and SSH. So inside SSH, you are going to see this particular thing, the SSH command that allows you to connect to your system. So let me go into, so I hope my screen is visible to all of you. And I'm going to go into, okay, so I'm going to go into repos, and all I'll do is, like, you don't need to run the first command. All we need to do is basically copy paste the command that we just wrote, that we just got from Microsoft Azure. In here, to actually use this command, you need to pass the path of the file that we have downloaded. So the file that we downloaded was my host underscore key uh, within brackets one. So I'm going to do that. I forgot the name. It's my host underscore key. I need to find the name of the file first, and then I'll write the command. An easy way to do that would be actually using the grep command. All you have to do is say ls grep my host. It does not exist. Okay. So this is the file that we want to pass as our security key. So what we're going to do is run the previous command that we got from here, copy this, We go back to our terminal, and now instead of private key path, we provide our actual path, like the path to this particular file, and that is going to be within my downloads folder. So I'll say downloads, downloads slash this file. Okay, so now I'll click on yes. And what this will do is this will basically allow me to connect. But now there is a problem that this is a public key and this cannot be used. On some systems it will work, and on some systems it does not work on the first time because of some security issues. So now basically the system is complaining that this file is public and it's completely accessible. It can be manipulated and hence might be corrupted. So to make it secured, we want to write this command called chmod 600. csmod 600 basically will make your file unchangeable, like unchangeable as in read only. It cannot be manipulated. It will from now on it will be a read only file. So just pass the path of the file with the chmod 600 command and downloads my host key 1.pm, no such file, not directory. All right, give me 1 second, guys. I'll just rename the file. It's all because of the space in the name, so I'm unable to use it. I'm going to say into downloads and I'll make it where is this particular file? I need to find it out. My host key.pem, right? Rename. I'm going to name it with my host key underscore dot pem. All right, so now we are going to pass this file name to our system and make it read only so that we can use it later. And it's going to be my host key underscore dot pem. So once you run this command, then we just need to run the previous command again and pass the file name now. And now it will work. It won't fail because it won't complain about the public key problem because that's already solved. Because after the 600 command, it's now read only mode and it's secured. So we just need to use it now. My host key pem. Yep. So when you run this command now, you will be dropped into your remote system. So you see now I am the name that it shows on my system is the Home, because if you remember that was the username we created while allocating our system, and it has my host, which is actually the name of the virtual machine which we chose, right? So in here, if I do ls, there is nothing, and obviously there is nothing because this is a new system. So this is how you create and access a virtual machine. Now what we are going to do is we are going to do a hands-on project and deploy it on our virtual machine. So are there any questions at this point? I hope not. Okay, so we are now going to deploy our system, deploy our hands-on project into the virtual machine. So the project I've already prepared it so that we all can be on the same page and start from here. I'm going to share this link with you guys in the YouTube comment. If someone can share this link in the comment, that would be great. Okay. Now, the way you can access this project is within your wherever you store all your projects. You have to go into that folder and just write this command git clone and paste the particular link that I just shared with you. If there is another easy way to do that, just go to the link and click on code and download it as a zip file. So the entire code base will be downloaded into your system as a zip file, just like it happened on my system right now, right? And you can unzip it and get the entire code. Or there is the C command line way to do it. Just write git clone and the project. So it will not clone on my system because I already have it on my system. So it will say that it's a default directory. Now I'm going to do into Azure Workshop, and in here it's a Node.js project. So you don't need to worry about the code because we as cloud engineers do not write the actual backend or the server side code. All we have to worry about is actually deploying this system into the cloud. So what do we need to know in order to deploy the system into cloud? We just need this we just need this data available, that is what kind of environment does the software require. So in environment definition, there's a package.json file which actually has the name of all the files that are required for our npm project to work. So we don't need to get into its configuration, how the backend actually works, how it processes the data. We don't need that. All we need to worry about is that the runtime is installed. The runtime here is node.js, and the dependencies are available to us. So what we are going to do is, to install the dependencies, you just have to write npm ci that will go into the package.json, right, and install all the packages that are required. And it's just one single command. Now the next step is writing npm start. Npm start will turn up your server and show this particular message on your screen. Now if I go to this link, this is the my software is now working, but it is available at this particular IP address or the URL. Now if you look at this URL, it starts with 127.0.0.1. Now this address is a local host address, or also infamously called the loopback address. So it's not a publicly accessible address. If anyone opens up, writes up 127.0.0.1, it will basically send a request to the system itself, because this address is a loopback address. It loops back the request into your own system, whatever is sent into this address. So we use this address to access the projects running on our system. Now 127.0.0.1, or you can also write local host in place of that. Basically both of them refer to the same IP namespace. So even if I do a refresh now, it basically is the same page, right? Cool. So within your system, the npm project is now running, and hence the local host is able to access this particular IP address, this particular project at port 8080, right? And now if we give some email ID, let's say I'll say team reskill, and I'll say the my particular name, and I give a profile picture. Let's say I go with an animated one, right, because it looks cool. And you have to click on sign up. Now if it will do some validation that the email ID does not already exist on the database, and if it does not, it will register you successfully, show a green tick. And now if you click on explore, you can see the list of all the people who have accessed your who have registered on your system. So it's me and my photograph. So that's all the project does. It allows you to register and see the list of registered users. So if I click on register again, and I use a new email ID, I provided a name, I choose a new picture, and I'll go with this one. It's an AI generated image, not important for the session, but it's a virtual photo. Like, this person does not exist. It's a virtual image, right? So there are some what do we say, there is some security built into it. If a lot of requests come, it blocks the IP address. So I'm just restarting the server, and if we refresh the page, you can see that both the people are now present here, like both the people basically called for the request. Cool. Now I'm going to do something in the server so that this particular rate limiting does not happen anymore. And I'm going to commit the code, git commit. This is not important. This is, I'm just doing that so that this problem does not happen on your system. Like, I did it for security, but it's not required now, right? Now what we want is, we want all this source code to be available in our remote system. So the way we'll do that is, we'll get the code base link from here, again the same link that is already provided to you on your YouTube comments. Now what we're going to do is, inside our virtual machine, we are going to say git clone, and get us the project here. Okay, sorry, it's the wrong one. Wait, I didn't copy the link. Okay, so I'm going to say git clone the repository. Now this will clone the repository and make it available to me. Now with this simple git command, I got the entire source code on my system. I'm going to go into the Azure Workshop directory, and now I'll say npm ci, and it will fail, because you'll see it will say that npm is not found and not installed. And as I said, to run your project on a virtual machine, you need to make sure that the required environment is present. And how do you do that? Basically, you can find the instructions in the GitHub repository that is shared with you. So to set up a cloud virtual machine, just you can copy the command from here, And these are the two basic commands that you need to install Node.js runtime on your system. So what I'm going to do is going to come back into the SSH terminal. I'm going to copy the command that we just pasted from my GitHub repository. This will go ahead and download all the basic dependencies that are required for installing Node.js. Do not worry about it. These are the texts that pop up when any system is being installed, software is being installed in your Linux-based virtual machines. It's very verbose. If you don't want this verbose, you can just quiet it up. Not a problem. It's just downloading the packages and it's showing what it's doing. It's sending a GET request to this particular API. Same. It's downloading a lot of things. And after that, you will see that now npm is installed, right? So sorry, not installed, as in this is the next step to install Node.js, and that is what this Cloud VM setup next step was. So once that is done, Node.js will be installed on your virtual machine. And then we will be able to successfully run this source code on our virtual machine. So the first step is installing all the required dependencies, and the command for that is again npm ci, as we saw in the previous command, as we saw while running it on our local host. So once npm ci successfully completes, it means basically all the packages are now available, and we can just say npm start, and it's going to fail again. Now the reason it fails this time is because I have screwed up. So I thought I have committed the right code, but it seems that the server.js is still missing. Give me 1 second, guys. I just need to make sure that the right command is limited out. Yeah, we are not using this limiter anymore, and that's the problem. Cool. So I'm going to say nano server.js. Oh god. npm start. This will start the repository with the particular link that we want. So here it says that the project is now listening at ACDP 127.0.0.1. Obviously, we cannot access this link from here. How do we access it? Is if we go to our Azure directory, we can go into our particular virtual machine. It's my host. Inside my host, in the dashboard, you can see a public IP address. So this is the address that you need to copy. And use it in our browser to be able to access the system. So I'll say this and I'll say 8080. Now, technically, this should open up the page and allow us to use the project, but it is not working right. And the reason obviously is something that we need to figure out. So let's see what could be the possible reason. Now, if we go into now I'm setting off the project from here. If we go into Azure and if you click on let's say network security group. So on inside here, you can see there are lots of things that are associated with our system. My host, which are a virtual machine, there is an IP address, and then there is something called NSG, or the network security group. So click on that. Click on your network security group, and in inbound security rules section, you will see that only these ports are publicly accessible and others are not. They are shut off. They cannot be, even though those ports are being listened from the inside, no requests are allowed to go into that. So we need to change this configuration in order to make our system publicly accessible, because we know that our project is listening on port 8080, and that is what we need. So to do that, we need to go into from the left hand side, select on settings, and inside that there is inbound security rules. So jump into that, click on add, so that we can add a new security rule. Make sure that you enter port 8080 in here, leave the service to be custom, and for the rest of these settings at its default, any hyphen. Yeah, in here you can give a name to your particular repository. Let's say Node.js, because now we are running a Node.js system on our virtual machine. Just click on add, and it will take a few seconds to add this new security rule to our system, or the network security group to be specific. Once it says successful, that means now the rule port 8080 link is now associated. So if we click on refresh, you can see that the port Node.js port is now accessible. The protocol is any, and it's listening at port 8080. So now if we go to the previous link that was not working and click on refresh, okay, it's still not working. The reason being we have stopped the server from here. So now we are going to say npm start in here. Let's wait for a while. It's now starting up. That's done, and we refresh the page in here. I hope I've copied the right address. I need to go into my host, and we have the public IP address in here. Cool. So it opened up, right? Now basically it is not rendering the CSS because we need some extra configurations and some CDN imports for that. Let's not worry about that. We have what we want. Our page is rendered, and we have the data that we need to work on, and the same procedure applies. So this is how you create a virtual machine, deploy your project, and make it accessible to everyone to use using a virtual machine. So it was a very basic fundamental exercise that we did today. This is definitely just one of the computing resources that Microsoft Azure provides you, but I hope this gave you an insight how your future projects can use Microsoft Azure to be globally accessible, because this gives you an edge in your resume, right? Because now you just are not describing your project in plain simple paragraph or text. Rather, you are deploying your project into the internet and providing the link in your resume so that the person who is reviewing it can actually go ahead and click on open up the link and test your project and use it firsthand. So that kind of experience really speaks for itself, and it's way better than a description on paper. So I hope this session gave you an idea how you can use this Microsoft Azure resources to deploy your projects into the internet for everyone to use, and that will give you an edge. And not just your resume, also in hackathons you can deploy your projects, you can leverage the infinite computing part that is available, and all those things. And when you are done, go to your all resources, click on name, and just delete all the resources that you created so that you don't run out of credits when you actually need it, right? That's the most important thing. And on that note, I think we are clear. Hey everyone, sorry, I had an issue. Yeah, basically, I just wanted to say that I hope this session gave you an insight how your future projects can use Microsoft Azure and you can deploy your projects online. And I hope the session was insightful, and we are open to questions now.
Basically, we have one question. Where is the link that you sent? Like, what links they push on one while
It's the GitHub repository link. One second, I'm adding it to the private channel. I hope you can share it with the students.
So, any more questions, guys? Anyone is having any doubt? Just feel free to ask your doubts in the comment section. Devisham is still here to solve your queries. If anyone is having any doubts, okay. I guess there are no further questions. Basically, so perfect. So one last announcement from my side, guys. Okay, I'm sharing one Discord link with you. This Discord link is of Azure Developer Community channel, Discord server, basically. We usually do a lot of stuff here. Like yesterday, there was a quiz where we gave swags to top 10 winners on Azure, and the next quiz is scheduled on February. Every Friday, we will schedule a quiz. So do join our Discord channel. Here is the link for Discord channel, and we will be hoping to see you there. And we do a lot of fun activities and a lot of announcement for Azure enthusiast, cloud enthusiast. So basically, do join the channel, and that's it. Anyone is having any doubt, so they can just ping us through in our Discord channel. Also, they can just raise a ticket. We are open to queries. So if no one is having any doubt, then we can just wrap up the session, I guess. Ronak, you have something to say, I guess.
So thank you so much, Dibyasom. It was real and amazing session. So I hope all of you got to learn a lot about Azure and you can soon implement Azure in your projects.
Okay, perfect. So thank you guys. Thank you, Devisham, for being our valuable speaker. Thank you, Ronak, for hosting this session. Thank you, everyone, for joining here. We are looking forward to see you in our Discord channel group. So see you then. Bye. Thank you.
Thank you. Bye bye.